Hey, 8th grade, this is Ms. Harkness, and this video is for Eureka, Module 7, Lesson 4, Simplify Square Roots. As you'll remember in class, we've been doing perfect squares, like 144, or 64, and 121. These are all relatively easy. Take the square root, 12, 8, and 11. But what happens when we have a number like 150 or the number root 360? You might want to say, oh, just type it in my calculator. What if you don't have a calculator? It's possible to simplify these by what's called extraction, by taking out a perfect square that is within that value. So we have to factor a little bit under the root, and then we'll divide out just the perfect square. So let's do a couple for an example. Let's start with a simple one, root 24. I know 5 times 5 is 25, but what number times itself makes 24? Not necessarily one I know. However, let's consider the 24 for a minute and write it as a factor. We could make 24 by doing 3 times 8, but neither of those are perfect squares. 2 times 12, neither of those are perfect squares. What about 4 times 6? 4 is a perfect square, so we can do what's called extraction. We can remove it from the root. So I will rewrite this as root 4 times root 6. Doesn't matter if we have two separate roots or both under the same root, same thing. So I'm going to come over here and I'm going to extract. I'm going to ask myself, what is the square root of 4? That's 2. 2 times 2 is 4. What is the square root of 6? Well, I don't know, but there is no perfect square, the smallest perfect square being 4 and then 9. So 6 is not a perfect square, so that will stay. It's just going to stay the root 6. So my answer here is actually 2 root 6, and then I'm done. That is my final answer. Let's try another one. What if I have something like root 90? 9 times 9 is 81. 10 times 10 is 100. 90 is not a perfect square, but I can rewrite it as the product of a perfect square and an integer. I know that 9 times 10 is 90. I'm going to, again, rewrite this as root 9 times root 10, just splitting up the radical. 10 is not a perfect square, but there is not one greater or smaller that I can factor out. However, we have this 9, so I'm going to extract out of the 9. Root 9 is 3, and the root 10 will stay. My answer here is 3 root 10. There's my answer. Let's look at a bigger number. What if we have something like root 600? I don't know that perfect square, and I don't think that it is, but I can factor it down to be 6 times 100. 600, which breaks down into 6 times root 100. Let's come do my extraction. 100, I'm going to extract out that 10. The root 6 stays root 6. My answer is 10 root 6. Let's do one more because sometimes they're not that obvious. If I have root 8, 10, for example, I see that right away, and I see 81 times 10. Immediately, I'm going to break that down into root 81 times root 10. If I do my extraction out of the 81, I get 9. And as you can see already, we've worked with the root 10. Stays root 10, 9 root 10. Hopefully this helps. Again, this is Ms. Harkness, and this is for Eureka, Module 7, Lesson 4.